Volcanoes. This is our last set of notes for geology. How exciting. Before we get into volcanoes, just a quick review. This is not bolded because you should already know it, but I just want to review it before we go further into it. So you have magma versus lava. And remember, magma is what is inside the surface or in the earth, molten rock that's below ground, when lava is molten rock once it's reached the surface or is above ground. So that's the difference in magma and lava. Important to remember as we reference it throughout the notes. So what is a volcano? Well, a volcano is simply a mountain of lava and pyroclastic material. Everyone say pyroclastic. Okay. Lava is the thing that most people think of when they see a volcano or hear about a volcano, and they think about lava being very dangerous. But really, what's most dangerous is the pyroclastic flows that you get from them. And I'm going to show you a video that actually talks about that and shows you a pyroclastic flow. But if you remember the eruption of Pompeii, Pompeii is famous because it had the bodies of people that were basically reduced to a substance kind of like charcoal, and an artist went through and made plaster molds of them so that way you could still go back and you could see some of the victims that were from that volcano. Well, the reason why their bodies were like charcoal was due to a pyroclastic material that was flowing through. So again, I'll show that on the next slide. You can kind of see the pyroclastic material, what looks like that really thick smoke in that bottom picture, but then you also have lava in the top picture. So volcanic materials. So now we're going to talk about two types of lava. I actually have two stones of lava that you can pass around and look at them. One of them is going to be the Pahoehoe, and that is going to have the twisted braided look, and the more rough jagged one is going to be the AA lava. So go ahead and start passing around those two lava stones, so that way everyone can see it as I talk about this, and then we can put them back after class. Now the Pahoehoe, which is just fun to say, I think that may be one of my new favorite words, it looks like twisted braids. So that's going to be what you see in like this picture and this one right here. The one next to it is just like a zoomed in version of it. To me, it kind of looks like brownie batter or cake batter. When you pour it into a pan, it kind of makes that rippled look. Well, the Pahoehoe lava actually has that same consistency. So if you think about cake or brownie batter and just kind of how thin and runny it is, that's very similar to what the Pahoehoe lava is like. And so if you look at the Pahoehoe as you pass it around, you're not going to notice many stones or crystals within it, because since it's so thin, it can cool much quicker. But when you pass around the AA lava, which is the other stone that's more rough, you're going to notice that there are some little green crystals that have formed within that lava. The reason the crystals form, because that would be a little bit more like an intrusive igneous rock, because it was much thicker, which I'll explain in just a second, and so it cooled much slower, and it gave time for those large crystals to form. So as you pass around that lava, just take note of those two things and then pass it to the next person. So the Pahoehoe is the twisted braided one, and the AA is a very rough, jagged type of lava. That's what you see in these bottom two pictures. And the reason why AA lava is so rough and jagged is because it's more of the consistency of like a thick toothpaste or like peanut butter. So it's going to flow much slower than your Pahoehoe would. But there's also a lot of gas bubbles that are going to get trapped within that lava. And as they kind of explode and pop out to the surface, kind of like, you know, when you're cooking bacon or hamburgers, the grease will pop. Well, you get those little like pops within this lava. And as the little fragments pop up, they cool and they harden that way, which gives it that really rough, jagged surface. So if you had a volcano that erupted with Pahoehoe, once it cooled and hardened, you could walk across it and you could walk barefoot and it would be fine. But if you had AA lava, you're going to want some thick boots on, because that's going to be a much more rough surface. Now, the last thing I want to tell you about the lava before I change slides is a lot of people ask, why is it that color? Well, lava is, or molten rock, is that classic fiery red, orange color. But remember, as soon as it hits the surface, that part of the lava is going to begin to cool. and it's going to begin to harden a little bit. And it changes colors as it does that. So you can think of that grayish black covering of the lava as like a thin crust that has kind of formed on the surface of it, and it's that different color, but it's still very, very hot. You could not touch it without burning your hand off, but it does give it that different color. So if y'all are still passing around those lava stones, that's fine, but I'm going to move on to our next slide. The gases that are in a volcano. Now, you don't need to write down the gases, but I did just want to show them to you. So within a volcano, you have a bunch of different types of gas, as well as the lava. 70% of the gases in a volcano are actually just water vapor. It's going to be obviously very, very hot water vapor, but there is a lot of water within it. 15% of it's going to be carbon dioxide, about 5% nitrogen, and 5% sulfur. Sulfur, if you know anything about it, smells like rotten eggs. So it's going to stink as it lets out some of that gas. Pyroclastic material is the other thing that you find within the volcano. And below or to the side, those are all pictures of volcanoes that have pyroclastic material coming out of it. Now, this you do need to write down. I think it's on the next slide. That will be better to write down. But the pyroclastic material, they can be very, very fine little particles, or they could be very, very large particles weighing several tons, kind of like stones or parts of volcano that are about the size of a car that get thrown out, mixed with little fine, like dust-like particles as well. The pyroclastic material is also very, very hot, which is something that makes it dangerous. So here's the part of the pyroclastic material you do need to write down. It's the hot gases, so it's not just gas, but it's very, very hot. It's glowing ash, it's going to have fire, it's going to have fragments of lava within it, and it's going to have rocks within it as well. And as it flows downhill, it can go very, very fast. They can be about 100 miles an hour, 450 miles per hour, or faster. It just kind of depends on the volcano. And as you can see, I hope that car can go really fast, but that pyroclastic material can also be very tall. So sometimes the pyroclastic material will shoot up into the sky, and I'm coming right back to this slide, but like this bottom picture right here, you have this big cloud of pyroclastic material that shoots up, and it may hover in the sky for a little while and then fall down to the earth and then start flowing. Other times, it just instantly starts to flow down the side of the mountain. So that's kind of what you can see here in this picture. And again, usually a car is not going to outrun it. Maybe this is a slower pyroclastic flow and this car is faster. Or maybe no one's in the car, but that is a picture of it. And again, I do have a video, so I'm going to let you pause this video and switch over to the next pyroclastic material video as soon as everyone is done writing. But go ahead and pause now. Another type of flow you can have on a volcano is something called a lahar. Everybody say lahar. A lahar is simply a mud flow on a volcano, but the mud flow, instead of being filled up with just mud, it actually has some of the pyroclastic material mixed in it. That's why it's kind of gray looking. It doesn't have to just be when there's a giant eruption. It could be if a volcano, has let out little teeny tiny eruptions and some of that material is on the surface of the volcano. And after a large rain, or these volcanoes can sometimes be very, very tall, and we know as you increase in altitude, you decrease in temperature. So some of that water can actually turn into snow, and if that snow melts, it can create a mud flow, bringing some of that volcanic material down with it. We'll talk more about mud flows in the next unit or two, but they can go very, very fast, about 50 miles per hour. Not as fast as a pyroclastic flow, but it's still fast enough to do some damage to homes and whatnot, and to remove trees straight from the ground, all of that. So that's what a lahar is, just a mud flow down a volcano, and it does have some of that volcanic material in it, which is why the color is the way it is. So that is your Lahar. Next slide. Before an eruption, how do you know it's going to occur? Do write this down even though it's not bolded. And again, always summarize so you can write faster. So before an eruption, your volcano is going to swell up. And sometimes the volcano will actually start to look a little bit deformed. So say the volcano is more of a triangular shape, then the volcano might start to have a more curved, rounded shape as it swells up and fills with lava. It's honestly kind of comparable to like a pimple. It festers and then it will pop. The volcano also can become eerily silent. So before I talk about the silent thing, earlier, before the volcano erupts, you're going to have more seismic activity, and that seismic activity is really talking to an increased bit of earthquakes. So you'll notice that there's a bunch of like minor earthquakes occurring all around the area, and kind of just consistently. And then all of a sudden, after all these earthquakes keep occurring, nothing. That's when it becomes very eerily silent. And you think, okay, well, the worst is over, all the earthquakes are done. But that's because the earthquakes were occurring because all the magma was moving up into the volcano. So the ground moved as the magma moved. But it's become silent because now the volcano is filled with lava and pyroclastic material, and it's all ready to explode out. So that's why it's a bit eerie. And the other thing that the volcano can start to do is release some toxic gases. So it'll basically start to smoke a little bit, or even if it's not smoking, it may be gases you just can't see as well. But especially like in Pompeii, one thing they noticed before the eruption was that the vegetation on the side of the mountain or the side of the volcano, it all started to die, as well as some fish that lived in the water next to it. And that's because all those gases were so toxic, it was killing the plants and it was killing the fish. In that pyroclastic flow video, that one guy was talking about it was hard to breathe. Well, it's hard to breathe because there's toxic gases being released. So it does kind of make you suffocate a little bit if you have a lot of those gases around you. So those are all the things that are warning signs before a volcano erupts. One of the largest volcanoes in the world is actually here in the U.S. It's in Yellowstone National Park. It's what we call a super volcano. And I always get a little bit freaked out whenever I start thinking about it. But that volcano is not expected to erupt for another 1,000 years or something like that. It's one of the most monitored volcanoes in the world, and there was at one point a rumor saying that the volcano is about to erupt. It's not. That was just something that people started to say, but scientists all say there are no signs of it erupting, which is very good for us because that would affect pretty much the whole North America. But there are signs, there are things we'll look for to see if a volcano is getting ready to erupt or not. So there is some warning we can have. Okay, so now let's look at a few types. Oh, no, before we get to the types of volcano, the ring of fire. So make sure you write this down. Again, summarize. Some of you may have heard of the Johnny Cash song, The Ring of Fire. If not, it is a classic, and you should definitely look it up. Or while you work on your study guides in a little bit, you can work to it while you listen to the song Ring of Fire. But all that the Ring of Fire is an area in the Pacific Ocean, and it has a ton of volcanic and seismic activity. And the reason it has so many volcanoes and so much seismic activity is because it's on a plate boundary. And so down here you have the picture of where the Ring of Fire is. It's outlined in red right there. And so here is the U.S. Notice that the Ring of Fire goes right next to where California is, where that transformed boundary is, which is where the San Andreas Fault is and all that stuff. That also is more towards the area where we have that large supervolcano. So any area that is next to the Ring of Fire is going to have more of these geological events occurring in terms of earthquakes, faults, and volcanoes, all three of them. You have Japan and Asia that are right there by it. You notice that a lot of the tsunami videos as well as the earthquake videos occurred in places that were near Japan or Asia, and that's due to it being close to the Ring of Fire. So that's what that is, and that's all I know to say about it. So if you aren't done writing, you can pause, but I'm going to go on to the next slide. Interplate volcanoes. Interplate is just talking about being inside of a plate. So a lot of times volcanoes can form along the edge of a plate, and I'm coming right back. But when I talk about come along or form along the edge of a plate, I'm talking about like on that line of the Ring of Fire. Interplate would be it's in the middle of a plate. It's not on the boundary or the edge of one. It's smack dab in the middle. And these can typically form from something called a hotspot. Now, this hotspot is not what you use to connect to the internet. It quite literally is what it sounds like. It is an extremely hot area of magma in the earth, inside that very middle of the plate, not along the edge of it, and it will come up and it will form a volcano. And in just a second, I'm going to pull up a little video diagram thing and kind of talk through how these hotspots occur and the movement that they create. Hawaii is one of the most well-known examples of a hotspot. So at one point, every single island for Hawaii was an active volcano, and then some of them have become inactive and weathered down to just islands, basically, while there still are a lot of active volcanoes around there because of the hotspot. So I'm going to pull up this video and I will show you how they form and how they move. So here is an example of where your hotspot is. It says there's a mantle plume over to the right. That is the hotspot. So as we play the video, this really hot spot, this really hot place in the mantle, lava will rise up and it will create a volcano. And that's what you see occurring now. So the magma rises up and boom, you have a volcano. Now remember, the crust is always moving. So for these hot spots, the mantle, this hot spot in the mantle isn't moving, but the crust is. So the crust moves and that volcano moves off of the hot spot. Now look at the volcano. Does it have lava or magma in it anymore? No. So we would say that volcano is now an inactive volcano. But over the hot spot, a new volcano forms. The crust continues to move, and as it moves away from the hot spot, now both volcanoes are inactive, and the hot spot will end up creating yet again another new volcano. This process will continue to occur forever as long as the plates are moving, and all these inactive volcanoes, the ones as they get further away, in a little while you'll notice that they start to weather or erode down, and they look less like a volcano and they'll begin to look more like an island. This is one of the best evidences that we have of plates moving, because you can literally see at one point this volcano was here and now it's moved off of the hot spot and it's just nothing anymore. So we now have 4 inactive volcanoes with a new active one constantly popping up. And in just a second, you can see they weathered down. So now you have what looks like an actual island right here with your new active volcano, and then these are all inactive because they are not filled up with lava anymore. So that's kind of how your hotspot works. It just will continue to do that. The mantle plume will just pop up and create new volcanoes while the other ones move away and they weather down. And that is how Hawaii came to be, just a long chain of islands, because they are a chain of what used to be volcanoes all forming over a hotspot. That's also why parts of Hawaii have so many active volcanoes. It all has to do with the hotspot that it's sitting on top of. So again, this video is in the notes, so if you need to go back and watch it, you can turn the sound on if I'm not helpful enough for you, and you can learn more about them. So let's switch back to notes, and now we can look at the types of volcanoes, and that is the last thing with volcanoes. So the first type of volcano is going to be a shield volcano. A shield volcano is called a shield volcano because it looks like a warrior shield. It's that if you imagine the volcano diagram you see on the bottom being a warrior shield that's just laying down, It's got a very gentle slope, so it's not steep, and it's not as tall. It's much more wide. And the reason why the shield volcano looks the way it does is because it has very thin, runny lava. So basically, these types of volcanoes, they constantly erupt. They're just very consistent eruptions occurring, but they're the least explosive eruptions. If you go to Hawaii, you can actually watch a shield volcano erupt from a distance. It's not going to be dangerous to you unless you're right there at it. But this really thin, runny lava that's not quite as thin as water, but more like that, the lava just like goes up and then out of the volcano, and it runs down the side of it. And as it's running down the side, because it's so thin and running, it cools very quickly. And so it's just adding another layer to the volcano every time it erupts. So these volcanoes have rings that kind of look like a tree ring. Rings of a tree tell you how old the tree is. The rings of this volcano are going to tell you about how many times it's erupted. So the thin running lava goes up and it just gently flows over the side, cooling and hardening. So you do need to know this is the least explosive volcano. Since you've already written that down, put a big star next to it. But you got the gentle slope with the runny lava, and because it's got such thin runny lava, you have the nice gentle slope of it. There's shield volcanoes in Washington, Oregon, and then, like I said, Hawaii as well. Cinder cone volcano. This is a cone shape, which is why it's called cinder cone, and this is one of the shortest living volcanoes. They're basically like a pimple. They can pop up on the earth and then just relieve a little bit of the magma and pressure that's built up, and then they just die and they move on and they aren't filled up with lava anymore. There actually was a Mexican farmer who looked out his window one day and noticed the ground was starting to rise up. Like, he noticed there's a hill and there wasn't a hill before. And he checks out the window a couple more times over the next few days, and all of a sudden one morning he wakes up and boom, there's a big volcano in the middle of his cornfield. It was a cinder cone volcano. It just popped up one day, and I don't know how long it stayed, but after it erupted, it went away, and then the farmer could have whatever was left of his field. But these volcanoes are shaped like a cone. They're very steep because they have lava that's, again, very thin, and that lava flies up in the air, and then it just falls straight back onto the volcano, making the sides build up in that cone shape. But that's the cinder cone. Then you have a volcano called the Composite, or the Strata volcano. They have both names, so I don't know what name you would see because you can use either one. So Composite or Strata volcano. These are very, very steep volcanoes, as you can see in this picture. They're very tall mountains that are very steep mountains as well. This type of volcano has very, very thick lava. It's going to be more like that AA peanut butter viscosity of lava. Because the lava is thick, it's what causes it to have the most violent eruptions, and that also is something that you need to know. So shield was the least explosive, the least violent. Composite or strata volcano is the most violent eruption. These volcanoes, because this lava is so thick, again, think about peanut butter. The lava that's at the very top of the volcano is going to cool and harden and basically create a dome or a lid. Some of you may have experienced this with toothpaste before. The very outside of the toothpaste will kind of dry up and harden, and then you squeeze and nothing's coming out of the toothpaste, and then all of a sudden when you squeeze a little bit harder and all the toothpaste just shoots out of the tube. Well, that's what's going on with this volcano, but in a much more deadly way. So the dome of it has caused all this pressure to build up because nothing can escape. And then all of a sudden, whenever these finally do erupt, it will literally blow the entire dome or the lid, aka the top of the mountain, off with the rest of the eruption. So that is, if you can imagine the force that's behind it, that's why these are considered the most violent of the erupting volcanoes. I can't remember where this picture was. Part of me wants to say Washington State. Remember, some people don't know this, but Washington State and Washington, D.C. are two different places. D.C. is in Virginia, and Washington State is west, way west, like more towards where Alaska is. So just in case you didn't know that, look at a map someday. But I think this volcano might be there, but I do think it's one of the volcanoes within the U.S., but nothing like compared to a super volcano. So now we are done with volcanoes. How exciting! Not only are we done with volcanoes, but we are done with all of the Unit 4 notes. And so all that we have left is chunk 2 of your study guide and then your test. So I hope you enjoy working on your study guide and that you have learned lots about volcanoes. And I will see you all very, very soon.